Hey everyone, today we are going over factors versus multiples, okay? We are starting our next couple lessons on GCF and LCM. So we have a couple of these definition squares that we'll be going over today. We're going to start off with factors. So GCF is two numbers in the greatest factor that two numbers have in common. All right, so if we're looking at this, let's refer to the numbers 12 and 18. So if you look over at the example, when we're talking about factors, factors are going to be your small numbers, okay? So that is a good characteristic of a factor. The numbers are small or they can be equal because in your factors, you can have the number that you start with. All right, so if we're looking at 12 and 18, when we're talking about factors and we look at this, a lot of us are familiar with a factor tree. So if I were to do a factor tree, which would look something like this, where I have the T, and I put the 12 on top, and we are going to start out with 1. So 1 times what is 12? 12. And then we'd move down the list. So next would be 2. 2 times what is 12? 6, very good. So after 2 comes 3. 3 times what is 12? 4. All right, so that is how we got our factors for 12. So go ahead and write down your factors for 12. All right, and then look at 18, and we would do the same thing. If we put that factor tree there, we would start out with 1, and we would have 1. We would have 1 times 18, which would give me 18. And then we would have 2 times 9, which would give me 18. And then 3 times 6, which would give me 18. Okay, so when we're talking about greatest common factor, it's when we're comparing two numbers. So we would find the number that is the same in the list, okay? It's that largest number that is the same in the list. So what is the largest number the same in 12 and 18? Good, it is 6. Okay, so that is an example of our GCF. Now we could do a non-example of what? What's the opposite of a factor? A multiple. So we could write the multiples of those numbers, and that would be a non-example. All right, let's go down to multiples. When we're talking about multiples, we're talking about our LCM. Our LCM is two numbers with the least multiple that two numbers share. So if we're looking at that, think about multiplying. When you're multiplying something, that number, is it getting smaller or bigger? It's getting bigger, so it's getting larger. So that is a characteristic of a multiple. The number is larger to the number given. It can also be equal, because if we are trying to find the multiples of 12, we would start out with that number 12, and we would skip count by that number. So for the number 12, if we found the first 4 multiples, we would multiply, each of those would be by 12. So 12, 24, 36, 48. And then go ahead and do 18. What would the first 4 multiples of 18 be? Yes. So if we're looking at those, between 12 and 18, which number is the least common multiple? So if we're looking at that list, which number, if we're starting from the left and moving our way to the right, which number has the same in both? Would be 36, yes. So if we're looking at non-examples of a multiple, what's the opposite of a multiple? Would be a factor. Very good. All right, so we're going to look at how to find factors using a factor rainbow. So first, when we're talking about factors of 10, we know that the factors are going to be our smaller numbers. So if I were to do a factor tree or a factor rainbow. Both of them are kind of the same thing. 1 times what equals 10? 10, good job. And then we'd move to the next number, so we would connect those two. And then we'd move on to the next number, which is 2. We're going to go in numerical order each time. 2 times what is 10? 5, very good. All right, the next number we would go to is 3. 3 times what is 10? You can't do that. Okay, so we'd move on to the next one. 4 times what is 10? There's nothing times 4, so we'd keep moving on. The next one would be 5. Do we have 5 already in our rainbow? We do, so we can stop. Okay, so that is how we do a factor rainbow. Let's list the multiples of 10. So the first 5 multiples of 10, remember, when we're doing multiples, we're just skip counting. Okay, so we would start out with the number 10 and skip count by 10. So it would be 10, 20, 30, 40, 50. Any questions? All right, so let's move down and practice our factor rainbow. We're going to start out with the number 36. Okay, so since we are starting with that, we always start with 1. 1 times what equals 36? 36, and we're going to connect that. All right, so we're moving on to which number next? 2. 2 times what is 36? 18, good. So we would connect that with the bow. What would be my next number? Good, 3 times what? 3 times 12 is 36. And we're going to continue in our numerical order. So 4 times what? 4 times 9. And our next number would be 5. 5 times what? 5 doesn't work. So we'd move on to the next number, which would be 6. 6 times what gives you 36? Very good. 6 times 6. Okay, so when we are writing those factors out, we want to start and put it in numerical order. So our factors would be 1, 2, 3, 4, 6, 9, 12, 18, and 36. As you can tell, I only put 6 in there once. Okay, you only need to count it 1 time. Are there any questions? Okay, we're going to do the rainbow factors for 40. I want you to take a minute and go ahead and try this one on your own. So you can pause the video and go ahead and try it before we go over it. All right, so 1 times what equals 40? Good, 40. Okay, then we would go to our next number, which would be 2. 2 times what is 40? Good, 2 times 20. And we're going to continue on with 3. 3 times what is 40? It doesn't work. So our next number would be 4. 4 times what is 40? Good, 10. So 4 times 10 is 40. What's my next number? 5. 5 times what is 40? Good job, 8. All right, we would continue on. 6 times what is 40? Doesn't work. What about 7? It doesn't work. Next would be 8, but we already have 8 on that rainbow, so we can go ahead and stop. All right, so let's go ahead and list those factors in numerical order. So we would have 1, 2, 4, 5, 8, 10, 20, and 40. Any questions? All right, we're going to go over how to find the GCF and the LCM. All right, so we already talked about finding the factors of our 12 and 18. And remember, factors are the numbers that are smaller than the original number. And when we talk about multiples, multiples are larger than the original number. So we're going to be using the wedding cake method in order to find both. Usually when we've done this before, we had to do two separate things to find them both differently. Well, this strategy helps you find both of them in only doing 1 times the work, okay? So if we're looking at this, it gets its name because it looks like a wedding cake, but it is really repeated division, okay? Remember, make sure that you write down these notes and you have them in a nice, safe spot so that you can refer back to them. To do the wedding cake method, you will break the numbers down using the numbers 2, 3, 5, 7, 11, 13, and ending with 1. What do you notice about those numbers? They are all prime. Okay, so those are prime numbers. When we are trying to find the GCF and LCM, we must use prime numbers. Okay, now when you get to 1, you are done. It rhymes. Should be able to remember that one really easy. Okay, when you're done, you multiply the side numbers outside the wedding cake for the GCF, and you multiply the side and the top numbers for the LCM. So side numbers are for your GCF. I'm going to try to color code it for y'all so that y'all can refer back to it. And then your side and top numbers are for the LCM. Now, again, it looks like a wedding cake. So remember, a wedding cake has different tiers. All right, so the bottom tier is the largest, and then it gets smaller and smaller and smaller. So when we are doing this first one, our bottom tier is going to be the largest. And we're going to start out with the numbers that they gave us. Okay, so they give us 6 and 10. So I'm going to start out with 6 and 10 in the bottom tier. All right, now I'm going to start at the beginning of my list, which starts with 2. Can 2 go into both of those numbers evenly? It can. So I put 2 on the outside. 2 goes into 6 how many times? 3. 2 goes into 10 how many times? 5. Okay, it has to go into both evenly. So now that we've done that, we can make our next tier. Okay, so we pick up where we left off, which is the 2. Can 2 go into 3 and 5 evenly? It cannot. So we're going to work through this list. So then we would go to 3. Does 3 go into both evenly? It goes into 1, but not the other. So 3 does not work. What about 5? 5 goes into 1, but not the other. So that one will not work. And we know we're now getting to the numbers that are larger than what's in the cake. So we know that those automatically will not divide into those evenly. So the only number left is 1. 1 goes into 3 how many times? 3. 1 goes into 5 how many times? 5. Okay, and remember, when you get to 1, you are done. So we got to that 1 right there, and we are now done. So now we're going to use what we have up here to find our GCF and LCM. So it says that the side numbers we multiply together to find that GCF. So these are the side numbers they're talking about. So what 2 numbers am I multiplying together here? 2 times 1. So my GCF is going to be 2. All right, and for your LCM, you multiply the side and the top. here's a trick for you. It kind of looks like an upside down L. So that's one way to remember that. It's an upside down L. So we would multiply 2 times 1 times 3 times 5. And remember, you can use your calculator. So when we multiply all of those together, what would we get? Answer would be 30. All right, let's go ahead and go on to the next one. Okay, so we have that bottom tier. What numbers am I putting in that bottom tier? 9 and 15, because that's what they gave us. That's in the problem. Now we're starting on our list again. Remember, we always start with 2. So can 2 go into 9 and 15 evenly? It cannot. So I'm going to cross it out, move to the next one. What about 3? Can 3 go into 9 and 15 evenly? It can. So I'm going to put 3 on the outside. 3 goes into 9 how many times? 3. 3 goes into 15 how many times? 5. Very good. All right, so now we're going to draw our next tier. Okay, so we pick up where we left off. We left off on the 3. Can 3 go into both 3 and 5 evenly? No, it can't. Remember, it can only go into one. It has to go into both. Okay, so that doesn't work. Same with 5. It goes into one, but not both of those, so it doesn't work. And then we're getting into the numbers that are higher than that, so we know that we've kind of gotten to the end of that. So we have that last number, what? 1. 1 goes into all those. 1 goes into 3 how many times? 3. 1 goes into 5 how many times? 5. And when we get to 1, we are done. So we have that 1 there and we are done. Okay, so let's go ahead and find our GCF. Remember our GCF, we are multiplying those side numbers. So what am I multiplying for my GCF? 3 times 1, which gives you 3. Very good. All right, and then next we are going to do our LCM. Remember, that is the top and the side numbers. It looks like that upside down L. Okay, so what numbers am I multiplying together for that? 3 times 1 times 3 times 5. Again, you can use your calculator. So what would be the LCM there? 45. Now remember, you need to make sure that you label them. GCF is this, LCM is this. You can't just throw numbers there because I'm not going to know which one is different from the other. All right, let's go ahead and try our last one. So we start off with our bottom tier. What 2 numbers go in that bottom tier? 8 and 20, because those are the numbers they gave us. And we're going to start over here on our list of numbers. What number do we always start with? 2. Does 2 go into 8 and 20 evenly? Yes, it does. So I'm going to put 2 on the outside. 2 goes into 8 how many times? 4. 2 goes into 20 how many times? 10. All right, so we're going to draw our next tier, and we're going to pick up where we left off. Okay, so we left off on the 2. We're going to pick up on that. Does 2 go into 4? Does it go into 10? Yes, it goes into both, so we can use 2. So 2 goes into 4 how many times? 2. Does 2 go into 10 how many times? 5. Very good. All right, so we're going to go ahead and draw our next tier. All right, so we're going to pick up where we left off. So we left off on the 2. Can 2 go into both of these evenly? It goes into 1, but not the 5. Okay, so we're done with the 2 now. We move on to the 3. Can 3 go into both 2 and 5? Not evenly. So let's move on to the 5. Can 5 go into both 2 and 5? It goes into the 5, but not the 2, so it will not work. So now the rest of those numbers are larger than the numbers we have. So we know we end with what? 1. 1 goes into 2 how many times? 2. 1 goes into 5 how many times? 5. And remember, when we get to 1, we are done. Okay, so now we're going to find the GCF. What numbers am I multiplying for that GCF? Remember, it's the side numbers. So we would take all of these on the side, which would be 2 times 2 times 1, which equals what? 4. So the GCF is 4. And now we're going to find the LCM, which is those side numbers and the top numbers. Remember, it makes that upside down L. That's how you remember LCM. So what numbers am I multiplying for that? 2 times 2 times 1 times 2 times 5, because those are all the numbers on the outside. So when I multiply those together, what do I get? 40. Very good. So we have the GCF of 4 and the LCM of 40. Are there any questions? All right. So you could go ahead and if you needed more practice on this, come up with 2 numbers and use your wedding cake method in order to work these out and just practice the skill. We will go over more of these later.